morning. Temina Khan is here in TKMaths is Fun. In today's video, we will see two questions rather, on the topic quadratic, which is a part of the syllabus of A-level mathematics. You can see my website and blog address. I'll show you what is in it. So in the topic quadratics, there are 5 further concepts you need to understand. In these 2 examples, past paper questions which I have taken in this video, I will cover the concept of discriminant and completing a square concept, right? So, and this is just one way of handling, because the question is asked in many ways, so I will make more videos on it. So let's see. So before we start the question, you can see on my website address, I have put down all the topics like this of the syllabus, and if you click on any, you will see the relevant questions. So it will help you to review or recap the topic or the whole syllabus very quickly. So it's a good resource for you. So let's recall few concepts of discriminant. When we're talking about discriminant, what do we mean? In the quadratic formula, this portion, which is b square minus 4ac, is called discriminant. Why? Because it helps you to identify what type of roots you will have. If discriminant is greater than 0, the roots are real, and there are 2 distinct rules. If discriminant is equals to 0, the equation has 1 repeated root. We will see the graphical explanation here. And when b square minus 4ac is less than 0, the equation has no root. So what does it mean? When discriminant is greater than 0, 2 distinct root. It means the curve will passes through the x-axis at 2 points. Or if you are talking about line and a curve, then line will cut the curve at 2 points. And if b square minus 4ac equals to 0, then curve will touch the x-axis if it is only curve, and if it is a line and a curve, then line will touch the graph at 1 point, maybe just like this, or maybe just like this, but at 1 point. Or if b square minus 4ac is less than 0, it means curve will not touch the x-axis, or if we are talking about a line and the curve, then they are not intersecting. So questions are framed around these wordings. And about the completing square form, you need to understand what important feature of the graph it highlights when you bring the quadratic general equation into completing a square form. So P and Q, because you put whatever is here equals to 0. If I put it equals to 0, I'll get x is equals to minus P. So minus PQ will be my turning point. And very important thing, what sign do you have here? If you have plus sign here, you get minimum value curve. And if you have minus sign here, like here outside, then you will have maximum value curve like it is here, right? So very important feature, it immediately gives you the turning point, it gives you the shape of the curve, it will be maximum or minimum. So let's see the question. The question is from March 2212, question 2. Equation and the curve equation and line equation is given to you. They both have one unknown c, which is a constant, right? The question is saying find the values of c for which the curve and the line intersect at 2 distinct points. So we have just seen when they are intersecting at 2 distinct points, it means your gradient will be greater than 0 gradient carrying. The discriminant will be greater than 0. So first of all, we will put them equal to each other and bring them in the general quadratic form. Why will we do that? Do you understand the reason? Like this is the curve equation, this is the line equation. I have put them equal to each other and brought them into this general quadratic form. The reason is the coefficient of x square will be my a, coefficient of x will be my b, and c is this whole constant. Do not get confused here by this letter c. By chance, the letter c is used here, and in general form also we use c. But by c mean constant. So this whole is my constant here. So now, because the curve and line are intersecting at 2 distinct points, I will take the discriminant greater than 0. So I will substitute the value of ABC in the discriminant, right? Greater than 0. And it will help me to form an inequality, and I can solve it and find the answer. So I will plug in the value of B here, and then I will simply expand it. I hope you remember the algebraic identity. which is a minus b whole square, a square minus 2ab plus b square. So I have expanded this by that algebraic identity, minus 4 plus 4c, and then of course this will cancel out and you are left with this. So if you take 4c common out, right? Now what is the common mistake students make here? Any idea? What students do generally here, they put this thing greater than 0. Now let me tell you. And they put c minus 3 greater than 0. This is what they do. And they do c is greater than 3 and c is greater than 0. Now this is the mistake here. You do not deal it like an equation. This was a quadratic inequality. So the immediate thing you get from here, that c, which is your unknown here, is actually in this equation is intercepting at 2 points, right? It is intercepting at 2 points, which is 0 and 3. Because if you deal it as an equation, c is equals to 0, c equals to 3. So these are the 2 points at which it is intercepting. The coefficient of c square was positive, so it will give you minimum value shape. And now because it is saying greater than 0, it means this part of the curve which I have highlighted here. So at this part of the curve, the values of c are here less than 0 and here which are greater than 3. So this is how you will get your two ranges of c here. Achha, do not make mistake here that this c, take it as an equation. So that is telling your axis. So your axis is your c axis here, right? Like we usually use x. So I hope you understand this question. So I told you the common mistake, you need to be careful how to handle quadratic inequality. Now this question looks easy, but this is actually a tricky question and a good question to develop the concept. I've taken it from June 2112, question number 1. When questions is expressed this in this form, most of the time what students do, they just open, expand it, and then compare it and state the value of an AB. Actually, when questions is expressed this in this form, so you have to show the transformation, that how this expression will become this, right? So let's do this slowly. So we know this completing a square form, when we bring it into, we try to make the coefficient of x square 1, number one thing, right? So this is what I have done here. I've taken 16 common out. Constant we keep untouched, so I'm keeping it out of the bracket. So when I will take 16 common out, this 24 will be divided by 16. After that, I will simplify it. It will become 3 upon 2x. Now, if you remember, when we do completing a square form, what do? We take the coefficient of x divided by 2 and square it. This gives us the term we have to add and subtract here to change it into perfect square form. I'm repeating the coefficient of x, half it mean divided by 2. So it will become x upon, okay, so it will become 3 upon 4 square. So this is the term I will add and subtract here, right? And this is, you can see I have done here 3 upon 4 square, add 3 upon 4 square, subtract. And now we know that this part will change into perfect square form, right? Because it is in the form of a square minus 2ab plus b square. So you will take x, 3 upon 4 and minus sign. And this term you're writing as it is. I have used different colors so that you do not get confused and you can get a clear idea. After that, I'll multiply by 16, this green and this red one terms. Now, this 16 will cancel with this 16, so I will have minus 9 plus 10. What will I do here? I will write instead of 16, 4 square. Now, I hope you remember the basic algebraic concept which says, it is here, which says, if you have a square, b square, and you can write it as ab whole square, complete thing. So 4 is a square and this term is a square. So what I'm doing, I'm writing it together and writing a square overall here, right? So you can see exactly this basic concept I have applied here. Now this 4 can multiply by this. Here 16 could not multiply by these. Why? Because this is not a square and this is a square. But now it is possible. So that's why I have applied this concept. So now when I will multiply it, it will be 4x minus 3 upon 4 times 4. Now this 4 will cancel out. So you will have 4x minus 3 plus 1. And the original form of the question was given this, 4x plus a plus b. So your a is minus 3 and your b is 1. So this is how you will transform that question into this form. Now the other part is a very concept based part. You don't need to do any working. Mostly students make mistake of actually started solving it all over again, but you don't need to. This you have already changed into completing a square form, and k is any number. You know, if it is any number, for example, if it is 2, and graphically if you see, it means he's talking about a straight horizontal line. So k is whatever number, it is actually graphically a straight horizontal line. This line will be y equals to k. If it is 2, y is equals to 2, whatever it is. We don't know, we have to find this out. Now question is saying given this curve and this line, I'm saying line because I know it's line. If it is -1, it will be below the x-axis. So this line and this curve is intersecting at one point because they have exactly one root. So intersection is happening at one point. So what will I do here? I have changed this into completing a square form, and this gives me very clearly the shape of the curve, which is something like this, right? I'm only talking about this red portion because this gives us turning point 3 upon 4 and 1. Am I right? If you put this equals to 0, I showed you in the recall thing. So x is equals to 3 upon 4. This is your x coordinate of the turning point, and it is 1. So this is your turning point. Now this curve is meeting with some straight line, right? Now for example, I draw line here. If I draw line here, it is intersecting at 2 points. Then the equation has 2 roots, but question is saying it has only 1 root. So the only possibility that it pass exactly through this turning point. Yes or no? It is little slant. Let me make it straight. Okay. So now this line will touch the curve only at one point. So I can call it x is equals to, k is equals to 1. Because the equation of this line will be y is equals to 1. Agreed? So equation of this line is y is equals to 1. So it means k is equals to 1 and the x is the root, which is 3 upon 4 at this point. So this does not need any working. It just need the understanding of the concept that k is 1 and root is 3 upon 4. So thank you very much for watching this video. Please press like and subscribe and give your positive comments to encourage me. Share it with your friends. Take care. Allah Hafiz.